Hello students, Mr. Giomini. Wanted to talk to you about lesson 1-2, writing algebraic expressions. Now this always has been a difficult task for students. So I thought I would answer some of the questions that look similar to the ones you have for evening practice. And the ones we did in class today. So let's take a look. It says write an expression for each word phrase. So we have to write an expression. I know an expression could have at least one or two possible variables, maybe more, who knows, and there's no equal sign. So I take a look at the first one. It says a number, p, so we're using the variable pre, increased. Now I automatically think, what does increased mean? Increase means add. And what am I adding to it? I'm adding to it 20. So this would just be simply taking a number and I'm increasing it, so I'm adding to it 20. And there I'm done. Okay, this one here, 11 less than a number n. This one always gets kids. 11 less than a number n. So I'm taking 11 away because it's going to be 11 smaller. So that must mean that I have to start with something in order to get 11 smaller than it. So, or 11 less than. So it becomes n minus 11. When it says less than, that means I must take the 11 away from something. So I have to start with something first in order to take 11 from it. Okay, the quotient of 36 and a number m. Quotient tells me to divide. So I'm dividing 36 by a number. I don't know what that number is, but we're going to call it m. So the variable is m. I can write it like this. I may also write it like this. Either one is acceptable. Alright, next one, 8 less than, looks similar to number 2. 8 less than a number, k, divided by 9. 8 less than, so that means I have to start with something to get 8 away from it. So that means my 8 less than is going to be my second part of this expression. Now, a number divided by, divide, that tells me division. So I'm going to divide k by 9. And then I'm going to take 8 more away from it and then get my answer. Okay, and again, you cannot solve these, boys and girls. You cannot solve and figure out what k is because you know equal sign. These are just expressions and they're not giving us any values to substitute in. I look at the next one. 9 times the sum of, 9 times the sum of a number d and 13. 9 times, I am multiplying 9 by something, but it says first I have to get the sum of that. Sum is to add, and I get the sum of d and 13, so I have to add d and 13. So before it doesn't say 9 times d, it says 9 times the sum of d and 13. So that means I have to get the sum first. Now let's see here, we have 9, we have multiplication, we have d plus 13. Now written like this says 9 times d plus 13. I have to get the sum first, so all I'm going to do is put these in parentheses. Because here, order of operations, PEMDAS tells me add before you ever multiply. So I would add these two first and then multiply by 9. Next one, the sum of, sum tells me to add 25 times a number w and 10. The sum of 25 times a number w and 10. I'm going to add, and tells me that it's going to add. I'm going to add 10, but first I got to times 25 and a number w. So it becomes 25 is my coefficient, w is my variable that could change. Remember, 25 is the constant. We're always multiplying by 12. And then I add 10. Now, because of order operations, I do not need to put this in parentheses because multiplication would always come before addition. If you wanted to do this, that is okay to show to multiply this first, but it's not needed because, again, multiplication would always come first before addition in PEMDAS. Okay, I want to stop right here because I want to take a look at the next page real quick. Now we have to translate each algebraic expression into words. So we're going to translate each algebraic expression into words. I'm going to use my keyboard here. Now this says y minus 7, so I may say, I'm taking 7 away from something, so I could say 7, or let's use the digit 7. 7 less than y, because I start with y and I take 7 away from it. If I go here, that really just looks like me. It's 12 times P. Simple enough. All right, if I go here, all right, now how would I start this? I could say, could I do the sum of 3, or I might do this, let's do this. 5 times the number, what number is that? I'm going to say it's n plus 3. Or could I say 3 more than the product of 5, let me write that out, or 5 times n. Either one of those would work. Okay, because multiplication and addition are commutative. Let's take a look at this next one. Okay, I have multiplication, but I have parentheses first, so I have to find that sum first. So I could do 10, is it a 10? 10 times the sum of 8 and w. I could do that because that tells me I got to find the sum first and then multiply it by 10. Now it says here, write an algebraic expression and use it to evaluate each word problem. So at a concession stand, hot dogs are $1.50. Hot dogs are $1.50, hamburgers are $3, and soft drinks are $2. Write an expression for the total cost of buying H hot dogs, B hamburgers, and S soft drinks. Find the total cost of 3 hot dogs, 2 hamburgers, and 4 soft drinks. So, going back to this problem, hot dogs are $1.50, or hot dogs equal $1.50 each. Hamburgers are $3, or we could say hamburgers equal $3 a piece. I can also go soft drinks. Let's see here, soft drinks. Go back to pink. Soft drinks equal $2 a piece. So I have to write an expression. There's going to be no equal sign here. So let's see here. Hot dogs are $1.50. So, and we could write an expression for the total cost buying H hot dogs, B hamburgers, and S soft drinks. So, well, each hot dog's $1.50. So I put my coefficient first, $1.50 times however many hot dogs I'd buy. I add to that how many hamburgers I'd buy, which are $3 a piece. So the coefficient comes first, 3 times B, plus soft drinks. Soft drinks are $2 a piece. I put the coefficient first, and the number of soft drinks I don't know, so I put S. Now it says to evaluate that when I find the total cost of 3 dogs. So now I have $1.50. No longer is it H, it's now $1.50 times 3, because I'm buying 3 hot dogs, plus I'm buying 3 burgers, and burgers are how much again? Go back to my original expression. I'm buying 2 burgers, sorry, so that's 3 times 2, plus I'm buying 4 soft drinks, so it's $2 a soft drink times 4. Okay, 3 times $1.50. Let me go up here. $1.50 times 3. Well, 2 would be $3. Another one would be $4.50. Let me just double check. 3 times 0 is 0. 5 times 3 is 15. 3 times 1 is 3 plus 1 is 4. Move it over twice. Okay, so that gives me $4.50. $4.50, not $450. That'd be an expensive hot dog. Plus 3 times 2 is 6, plus 2 times 4 is 8. Let's do some addition here. Let's go with, I'm going to go 8 plus 6 is 14. I then go $14 plus $4.50. That equals 0. That's 5, 8, $18.50. All right. You can take a look at the last one there. That might be a great challenge problem for you. Might be worth trying to solve it. And I'll tell you what, if you solve this problem, write an expression for it, you bring it into class tomorrow, and then figure out what the cost was before taxes, I will give you, let's just say, 5 bonus points. Okay, have a great day. Take care.